Hi everyone and welcome to my new video. In this video we are going to be talking about this device that I did. So it is a timer switch. We can use the device if we want to control a device at home or at our workspace, depending on some intervals throughout the day. For example, if you want to have a device that has to be turned on, for example, on Monday from 12 p.m. to 3 p.m. and on Saturday, for example, from 3 p.m. to 10 p.m. I'm just giving you an example. So this device can help us to do so. So before I start, I want to say that if you like these type of videos where I'm talking about some electronics that I'm gonna do, and everything related to technology, please consider subscribing to my channel. It means a lot to me and it helps me, motivates me to continue doing and exploring and sharing with you what I've done. In the video I'm going to share everything. So I'm going to be talking about the electronics, the app that I did and I published on Play Store, so you will be able to download the app, recreate the electronics, and if you need a device like this one, you will be able to do it easily. So we've got an ESP32 development board, that is the brain of the electronics part. We've got an RTC module. It's got a tiny battery here that is here to help us, and it helps us to retain the time, the configurations that we had done to the board. And even if the electricity goes down, it will store that time and it will keep the time without any problem. We've got an optocoupler here. It is here to help me to see whether the battery is okay or not on the RTC module, and I've got these two wires here to inform the user and turn on an LED and inform the user that something has happened to the battery and the battery is not okay, so we need to change it. I use the optocoupler to cut the VCC for a while and test whether the battery is okay, because the method that the RTC library gave me didn't let me know whether the battery is okay or not if I've got the VCC put when I'm checking whether the battery is okay, whether the condition of the RTC module is okay. So I decided to use an optocoupler, cut the VCC for a while, and after that check it and see whether it is okay or not, and continue with the program if it does, or light up the LED if it's not. We've got a relay to control the load, and we've got a AC to DC 5-volt converter in order to power up the board and every module that I've used. So maybe there are going to be people that are going to say, you know, there are timer switches that are available online and they are cheap. So okay, so they are available timer switches. I've tried some of them, but to be honest, I didn't find the one that works without any problem, and I wanted to have some options that weren't available on that timer switches that are cheap online, so 20-30 bucks. So but maybe if I find some timer switches that are available and that are cheap, still I will choose the hard path, because that's my hobby. I enjoy doing electronics, I enjoy soldering things, and that's something that makes me happy. So I soldered everything and enjoyed a little bit. So that's something that I like. So that's about the electronic. Here is the pinouts that we've got to follow. So if you want to recreate it, these are the pinouts. So just pause the video and do them. The only thing that I would like to discuss is this one, the optocoupler. As I said before, I'm using it to check whether the battery is okay or not, or that the 3.3 volt from the ESP32 goes through the optocoupler pins. So one of the pins, or the emitter, goes to the 3.3 volt and the collector goes to the VCC of the RTC module. And also I've got 220 ohms resistor just to reduce the voltage and to save the LED. So that's about the pinouts. Pretty simple. I don't think that there are things that can be discussed here. And we've got the app. I created the app using Unity. So if you want to recreate the project, you can go to your Play Store and search for Talk to ESP32. That is my application, so download it. After downloading the application, here it is. We've got a menu here. I have done some other examples, so they are all linked with some other videos that I've posted on my YouTube channel, and you can search for the video. And also down in the description, in every video I've got a GitHub repo that you can use to download the code and use it and recreate the example here. So I've got some other example like voice commands and start some equipment and devices at home or somewhere else with voice commands and so on. So you can search for your example that you wanna recreate. So in this video we are interested about the timer switch, and it says waiting for Bluetooth connection. So I'm going to need to power up the board. So the board is powered on, and the app still says waiting for Bluetooth connection. So I'm going to turn on the Bluetooth. That is the device that we are interested in. And here it is. We've got Monday to Sunday, and we can set different starting times and ending times for the relay. So today is Thursday, and now the time is 13:41. So I'm gonna set it to 13:43. That is the starting time. I'm not interested about the seconds, and the ending time of the relay will be 13:45, for example. And we've got to click on the save button. I've got to be careful because I've got AC voltage here, so that can hurt me. I've got the multimeter, and it is set to continuity, and it will beep or when the relay is gonna be activated. We are gonna wait for that moment. It has to be activated at 1:43. So when I pressed on the save button, I used JSON format, and I sent the JSON to the ESP32 over Bluetooth. When I got the data on this side, on the controller side, I deserialized the data and I stored the data inside of the EEPROM. And I did it because if the main electricity goes off, and here it is. As you can see, it is turned on. So I stored the data inside of the EEPROM memory because if the electricity goes down, we've got to have an option to save the parameters that we previously had set, and to avoid setting them every time when the device restarts. We are gonna wait until 45. So I will cut the video in order to avoid hearing the beep. Also, one thing that I did, when we press on the save button, it gets the system time from the phone, and it sends it over Bluetooth, and it adjusts the RTC module that way. So we are sure that the time is properly set. And here it is. As you can see, the relay turns off and it works as it should. So let's try carefully to get the battery out, and we are gonna set the probes here. I'm gonna set it to voltage measurement, and I'm gonna restart. And as you can see, we've got voltage here, meaning that the LED will be turned on if we don't have a battery put. So I'm gonna put the battery now, change it, and restart. And as you can see, it works as it should. Now I'm gonna jump to my computer and show you the code that I wrote, so you will be able to understand it and do your own similar project and use it for your own purposes. So let's see what we've done. So let's see the code that we've got. So I'm gonna post a link down in the description from the code from the GitHub repo, so you will be able to check it and download it and upload it to your ESP32 board if you wanna recreate the project. So let's see what we've got. We've got the libraries that I used, some pinouts, some other local variables that I'm using for storing the hours, minutes, seconds, or starting hours and minutes and seconds, and ending hours, minutes and seconds. We've got some other local variables that I use throughout the code, some other objects. Let's see the initialize RTC module and the method that I was talking about previously. So this is the method isDateTimeValid that returns false if the battery of the device is low or even missing, if something has happened to it. And I figure out that if the VCC is connected to the RTC module, the method always returns true. So I decided to use an optocoupler and disconnect the VCC from the RTC module only before I'm calling this method. And if it returns false, so can device work, a local variable is going to be also false. That will help us to determine whether we will continue with the code or not. If the battery is okay, if everything is okay, we are gonna activate the optocoupler again, and the VCC is gonna be put to the RTC module, and everything's gonna be as it should. So if everything is good with an initialization part, we are checking the Bluetooth serial, and so we are retrieving the income string from the cell phone, and we are storing that string into a local string variable. After that, so everything is okay when we receive the Bluetooth command, we are deserializing the JSON inputs. So after receiving the JSON data, we are deserializing the data and putting the data inside of a local variables. And we are setting the RTC module, so we are adjusting the time and everything that we received from the cell phone. And we are saving the data to the EEPROM. So I dedicated some addresses on the EEPROM memory for different data. For example, T1 hours are stored from 0 to 6 address of the EEPROM memory, and from, for example, 7 to 13th location are stored the minutes and so on. So I'm storing the data, and so that's basically it about the receiving part. We've got some other method like ping Bluetooth device that I use to say that to the application that device is still activated and that everything is okay. And here in the execute time conditions, we've got the condition that I use and when I am checking whether I need to turn on the relay or not. So I concatenated, for example, the hours and the minutes, and I stored them into a string variable. And after that, I converted it into an integer variable. And that way, I am checking whether the current comparison time, for example, is bigger or equal to stored comparison T1 time, and so on. So I'm checking whether I need to turn on the relay or not. As you can see, in the loop function, we've got very few things, so it is easy to be managed, it is easy to be read. And that's my goal, that's my method of working. So I'm trying to divide the code and different functionalities in different methods or functions, and that way it is easier for me to go through the code and see whether something can be changed or improved or something else. So if I've got more than 2 lines of code for different functionalities to be achieved, I am dedicating a method for that. If it is less than 2 lines of code for a different functionalities, I'm writing it inside of the loop function because it is easier for me that way. So here, that's basically it. So that's the code. Go through the code, so it is not something complicated. So thank you for watching, guys. Please subscribe to my channel if you want to see some similar projects. So we're gonna see each other in one of our next videos. So bye bye.